Hi guys, this is Dr. G here, and in this particular video we will talk about aromatic nitration. So for this particular reaction you are going to need a catalyst as well as nitric acid as your reagent. So basically what we are going to do here is that we will react nitric acid and sulfuric acid, and this reaction will basically result in a nitronium ion. This reaction will basically result in a nitronium ion. So this nitronium ion is the electrophile that we will use for this electrophilic substitution reaction. Remember, this aromatic nitration is actually a substitution reaction where one of the hydrogens of benzene or your aromatic compound will be substituted with a nitro group. Okay, for this reaction, we need an electrophile. So the electrophile is formed using sulfuric acid and nitric acid, and the dehydration of nitric acid will basically give you a nitronium ion. So this nitronium ion will act as our electrophile. This right here is going to be our electrophile. Okay. All right, so this is electrophile. Why? Because on the nitrogen atom you have a positive charge. Okay, so if you are electron deficient like nitrogen, you like electrons. Okay, so nitrogen is electron deficient, so therefore it likes electrons. That is why it is known as electrophilic. Okay, so here is our benzene. So let's see how this reaction is going to happen. Okay, so benzene, one of the triple bonds on benzene can be used to attack nitrogen, okay, or the electrophilic nitrogen, and then you will get a cation, carbocation with nitro group attached. Okay, so this is how it looks like. Okay, so of course this carbocation is highly unstable. This carbocation is highly unstable. Why? Because it no longer has the aromaticity. Remember, benzene structure has a planar ring and 6 pi electrons that are conjugated, which means benzene is an aromatic compound. These aromatic compounds are extremely stable due to this conjugated pi electron system. So this reaction basically breaks that conjugated pi electron system. So you no longer have the aromaticity. So therefore this one is highly unstable. Okay, this is a endothermic reaction. So this is highly unstable. So therefore what happens is it will basically break this carbon hydrogen bond, because this carbon has too many bonds. Okay, so you have to break this carbon hydrogen bond onto these two carbons. To do that, a water molecule basically will absorb this hydrogen or attack this hydrogen, and then this bond will break onto the two carbons, giving you the aromaticity on benzene, There you go. And then here is our new NO2 group. Okay, so this compound right here is also known as nitrobenzene. Okay, so that is the reaction, that is the complete reaction. The only thing that you need to remember is that for this reaction you need nitric acid and sulfuric acid, and the reaction between nitric acid and sulfuric acid basically will give you a nitronium ion, which is our electrophile, and then the benzene will attack the nitronium ion, giving you a nitrobenzene, a substituted nitrobenzene. So basically what happened was the hydrogen on benzene is substituted by nitro group. Okay, by a nitro group. All right, so that is pretty much everything that you want to know. But in the exam I might even ask you to draw the resonance stability of your intermediate. Okay, so this is your intermediate. Here is your intermediate with a positive charge here and the nitro group right here. So if you want to show resonance structures, what you could do is you can use this double bond next to the cation, and then you can make a new double bond between these two carbons by breaking this double bond. So here is that resonance structure. So you no longer have this carbon-carbon double bond, instead you have a brand new double bond here. And this carbon lost a bond, so it will be positive. And then once again you can have another resonance structure by using this carbon-carbon double bond. Let me complete the structure. All right, so what happens here is that this double bond will break into these two carbons. So now you will have a new carbon-carbon double bond on these two carbons. And here is the positive charge. Okay, so these are the resonance structures of your intermediate. Okay, these are the resonance structures of your intermediate. All right, guys, please let me know if you have any questions. Okay, you guys take care.